Hello. The actual video starts a little later. Actually, I saw the video and I think that there is something that I have to make clear. And that's why I am recording it and I will inject this part in the beginning of the video. So video will start after some time. Look, this is A union B complement. Okay, in this video I have talked about the De Morgan's law, absorption law, and there is something that I want to, make it clear. A union B complement. X belongs to A union B complement. Okay, this is your first jump. This implies that X uh, does not belongs to A union B, and this means that X does not belongs to A and X does not belongs to B. If X does not belongs to A union B, this means that it does not even belong to A or it does not even belong to B. What is this is nothing but X belongs to A complement and X belongs to B complement, and then this means that X belongs to A complement intersection B complement. Okay, now from here from here X belongs to A union B complement. Here X is any arbitrary X, so any X that belongs to A union B complement, that X also belongs to A intersection, sorry, A complement intersection B complement. Okay, so every element of A union B complement is also an element of A intersection B complement. So this means that A union B complement is a subset of A intersection A complement intersection B complement. Okay, actually we will see that they are equal. And how to show two sets are equal? By showing that this set is also a subset to this. Okay, now in the video what happens is I have directly, after doing this, I have directly said that these two are equal, but that is justified in the video because in the video I also have a Venn diagram alongside this. So whatever expression that comes out to be, there was a Venn diagram to verify it. So in the video it was justified, but I thought that maybe it gives the wrong impression that directly from here to, if you jump from here to here, it means they are equal. That's why I thought that it is to, I have to make it clear. So now I'm going to prove that this is also a subset to this, and that's why both are equal. So let's take A complement intersection B complement, then X belongs to A complement intersection B complement. This means that X belongs to A complement or X belongs to B complement. This means that X does not belongs to A or X does not belongs to B. This means that X does not belongs to A union B, which means that X belongs to A union B complement. So for any X that belongs to A complement intersection B complement, you are getting that X to also be belonging in this set. That's why what we will say is that A intersection A complement intersection B complement is a subset of A union B complement. And from looking at these two, we say that actually these are equal. So A union B complement, this set is nothing, is same as this set. Okay, now in the video this part was not done, so I have injected this video. I have made it separately and I will inject this at the beginning of the video. Now, the video is length is about 40 minutes. Okay. So whenever ever, now it is upon you that whenever you see that if I have just gone from here to here and have directly said that these are equal, then there was also a Venn diagram to support this. Okay, number one point. And number two point is because I already know these results. That's why I forgot to. I knew that these two are same. This is a formula, De Morgan's law. So I knew it, and that's why I just did that in a haste. Now watch the video. Okay, in the last video we revisited union, intersection, and complement, and we saw that there are two ways to deal with properties of sets. To deal with equation involving set and set operations. One is Venn diagram, and the other is using the very obvious definitions of union and intersection, because those definitions are a kind of like a Boolean statement. For example, if I am saying that x belongs to A, then the value of it is either true or false, right? So anything like, for example, A union B is equal to, it is something like x belongs to A or x belongs to B. The value of this entity is either going to be true or false, and they are connected using a connective. So it is very much like think of it in case of propositional calculus, right? So in this video we will focus mostly, maybe Venn diagram also, but mostly into this approach, because this is a statement like the statement that involves Boolean values. So there can be many inferences made from this statement, and then you get something, then you get something. So we will see that how to do this type of inferences. A union B, this is equal to x such that x belongs to A or x belongs to B, right? This is one set operation which is union, and the another set operation is intersection, which means that A intersection B, this is equal to x such that x belongs to A and x belongs to B. So, or just like in the propositional calculus, what is the or operation in propositional calculus? For a or statement to be true, any one operand has to be. So for an element to be a part of A union B, even if it belongs to A, then that is in A union B. If it belongs to B also, it is also in A union B. An element is given to you, let's say Y, and you have to. This is called set membership problem also. That if an element is given to you, whether this element is a part of set or not. So if this element belongs to A union B is X belongs to A or X belongs to B. When you have this OR statement here, you evaluate from left to right, and in the process, if you get true, you don't need to evaluate the rest of the steps. Y belongs to A or Y belongs to B. Let's say this is false. Then you cannot say whether Y belongs to A union B unless you check Y belongs to B or not. But if this was true, if Y belongs to A was true, then definitely Y belongs to A union B. In case of intersection, you have AND here. AND means in AND operation, in propositional logic, AND operation means that the left side and the right side, um, left proposition and the right proposition, both has to be true to for whole statement to be true. So A intersection B, as the name suggests, it's about the common elements. So it has to belongs to A and it also has to belong to B. Complement. Complement means A complement. A complement means what? A complement means X does not belongs to A. Okay. And simple A set means that X does not belongs to A complement. That's why complement, they are partitioned to the universal set. We have seen this in the last video. In this video, what I am going to do is I am going to use different expressions and try to infer using this. So if I perform A union B, if I perform the complement to A union B, let me perform the complement to A union B, then what does it mean? A complement means X does not belongs to A. So A union B complement means what? X does not belongs to A union B. This is your first jump. What this means? From very basic definition, this means this. Okay. Now you know that if it does not belongs to A union B, what is A union B? A union B means it either belongs to A, or if it belongs to B, then I will include it in A union B. So if it is in A or if it is in B, I am going to include it in here. But I want those X that does not belongs to A union B, means I want these regions. I want these regions, right? The regions that does not belongs to A union B. So what does it mean? It means that X does not belongs to A and X does not belongs to B. Right? X does not belongs to A. X does not belongs to A means X belongs to A complement. And X does not belongs to B means X belongs to B complement. What does this mean? This means that X belongs to A intersection A complement intersection B complement. A intersection B is X belongs to A and X belongs to B. So X belongs to A dash and X belongs to B dash means X belongs to A dash intersection B dash. Right? Okay. Let's apply complement to intersection. A intersection B complement means that X does not belongs to A intersection B. Okay, what I basically mean, X is not in this region. X should not belongs to this region. Now, if this will become X does not belongs to A complement, or X does not belong, X belongs to A complement, or X belongs to B complement. A complement will take everything apart from A. So it may include B, but this region, which are exclusive to B. Okay, but A complement does not include this region, which has to be in it. So B complement includes those regions. Got it? So, and this is what your De Morgan's law is. If you remember in your from propositional calculus, I mean, I have uploaded 2 videos, maybe not in the whiteboard, but I mean, as of now. But I have uploaded almost 2 or 3 videos on propositional logic, which includes these basics, complement and and operation and or operation. I hope so. So from there also you in there in your propositional logic, what was your De Morgan's law? De Morgan's law was applied between or and, right? So in case of De Morgan's, if we remember, P1 or P2, or is like this, right? This is or P1 or P2 complement. This is nothing but P1 complement and P2 complement, right? So here it's almost the same thing. It's almost the same thing. Means, okay, how can you write this? Okay, so next step is nothing but if I have to just show it in terms of the operations, A complement or means union B complement, right? So I can say from here, from this I got this. So I can say that A union B complement is equal to nothing but A complement intersection B complement. And from here, A intersection B complement, this is equal to A complement union B complement. A complement union B complement. So you got this, right? So you know this is the De Morgan's law in propositional calculus. And what are you doing here? It's like you have not operation outside of P1 or P2. Then what happens because of this? To the propositions you perform the complement and or becomes and, right? Similar case is happening here. X does not belongs to A union B means, and A union B is what? A union B is what? X belongs to A or X belongs to B. So what is happening is that here the propositions is getting complemented. Here you are getting your set is getting complemented, right? X belongs to A complement. X belongs to B, so X belongs to B complement. And here the OR operation in your propositional calculus is getting into and here also this OR is becoming AND. So this is what complementation does. You can relate it from propositional logic. So in complementation, what happens is you just remember it. The set gets complemented, or union becomes intersection. Set gets complemented, and intersection becomes union. And that is your De Morgan's law. The name is same for both. In case of okay, if I do the De Morgan's law in the opposite manner, this is OR. So if P1 and P2 complement, this is equal to P1 complement. This is AND, so this is OR P2 complement. We have seen this in mathematical logic. So same thing is happening here also. You have A intersection B. So in place of propositions P1 and P2, you have two sets, A and B. So A intersection B complement. The result is set complement, A intersection. Intersection becomes union, set complement. So when you are performing this does not belongs to, then set gets complemented. When X does not belongs to something, then the set will get complemented here. First, I am complementing this OR into AND, but X does not belongs to A. I have written it here. Okay. X belongs to A complement means that X does not belongs to A. And X belongs to A means that X does not belongs to A complement. So X does not belongs to A means X does not belongs to A means X belongs to A complement. X does not belongs to B. X does not belongs to B means X belongs to B complement. So this is very simple actually. You have, okay, let me just summarize it. Okay, how many basic set operations are there? Union, Union is your basic set operations, intersection, and complement, right? You know the basic definition of union. It is that x belongs simple x belongs to A or x belongs to B. Basic definition of intersection is x belongs to A and x belongs to B. And when you are applying complement over any set expression, then what you will do, I mean, that is involving equal sign. Let's say you are doing complementing both sides, something like this. So whatever, if to a set expression you are applying complement, then what is the resultant expression directly you can get? How you can get it? You will just change this union into intersection and a set to complement. Okay, A or A complement, then A, and it is vice versa. Got it? So that's what you have to do. Okay, now we have two more, symmetric difference and set difference. So let's look at some of the properties of the symmetric and set difference also. Symmetric, just like we see that this union operation, this or operation, you can, the analogous in the mathematical logic is the or operation, and this and is nothing but and operation. So similarly, symmetric difference is nothing but like the XOR operation in the propositional logic. So A is symmetric difference B. What the basic definition of it is? It's like this: X belongs to A means I want exclusive part of A and B, right? Not the intersection part. Everything but except the intersection part. So if this is your A and this is your B, then apart from this intersection part, all of it is in A symmetric difference B. So it's like X belongs to A, but it may include elements from here also. So you have to add that, and X does not belongs to B. So this portion is covered. Or X belongs to B, but you have to make sure this part of B is not included. So and X does not belongs to A. Right? This is your definition, direct definition. Now, what can you infer from this? What can you infer from this? X belongs to A and X does not belongs to B. Look at this part. X belongs to A and X does not belongs to B. This is A intersection B complement. X does not belongs to B means X does not belongs to B means that X belongs to B complement. So this part is A and B intersection B complement, right? Or means union. Or means union. Then look at this part. X belongs to B and so intersection. X belongs to B. B intersection. X does not belongs to A. X does not belongs to A means X belongs to A complement. So B A complement. So what do you get from here? You get that A symmetric difference B asymmetric difference B equal to A intersection B complement union B intersection A complement. I am just writing it in terms of set operations, and you can verify it very easily from means this and this is the same thing, and you can see clearly A intersection B complement is this region, B intersection A complement is this region. Let's do something. Let's do the complement of asymmetric difference B. Okay, so we have the Venn diagram here. So we know what the complement of A symmetric difference B should be. From the Venn diagram, you know, if this is your complete Venn diagram, including the universal set. Now let's perform A symmetric difference B union. Let's see what we will get. From the Venn diagram, tell me what should be the region? Tell me. Oh, asymmetric difference B का complement Venn diagram से देख के बताओ कि कहाँ होगा. So it should not include this region and it should not include this region. So apart from that, this belongs to the complement of this, and all of this also belongs to the complement. Right? So if when you perform a complement to this, means that you are complementing on both sides of the equation. Now you can just do the De Morgan's law, and whatever the result would be, that result would include these regions only. Okay. So there are two things you can think about this. Number one, you can perform De Morgan's law and come to the solution. And you have your Venn diagram in place to verify if your solution is matching or not. Or you can directly give the solution by looking at the Venn diagram. That okay, this means okay, just by looking at the Venn diagram, what should be the solution? I am just writing that solution. Uh, where should I write? I'm just writing that solution here, okay? Just by looking at the Venn diagram, what should be the solution? So the solution should be this region is A intersection B, A intersection B, union. What is this region? What is this region then? This region is clearly it belongs to A complement, but not this part. Means that A complement intersection B complement. Can I say that A complement intersection B complement? Because I don't have to include this region. So B complement will have everything, but it will include A also. Regions of A in it means regions of A which is exclusive to A and not B, not the common elements of A from B. So it B complement will include this also, but because I am doing intersection with A complement, so this is in the intersection region will be just this. Now let's take the De Morgan's law and see if we are arriving to this or not. One more thing, while I was writing directly from the Venn diagram, I thought of writing A complement. So A complement will include everything apart from A, but I wanted to subtract B from it. So I wanted to do something like this: A complement minus B complement. No, A complement minus B. I wanted to do this. If you see, there is no problem in this. If you write this also, this is also correct. Because it will from the set A complement, it will remove the elements of B only. It will remove those elements in from A complement. It will remove those elements that are also in B. So it both of them will give the same result only. But why I chose this something like this, because I am going to use the De Morgan's law, and De Morgan's law involves union, intersection, and complement. So let's apply the De Morgan's law here. So let's say this is C, and let's say this is D. Then now this is nothing but C union B complement. So it is from De Morgan's law, C complement union का intersection D का complement. Now what is C? C is A intersection B complement. So A intersection B complement intersection D is nothing but B intersection A complement का complement. Now perform this. This is nothing but A complement intersection का union B complement का complement means B intersection B complement intersection का union A complement is A. This equation and this equation are just two ways of representing same regions. Let's see that A complement will include everything apart from A, but it will also include B, and B complement will include everything apart from B, and it will also include A. Okay, but then you are performing intersection, so this will include only this region. Got it? Means I got it, but it is messy, so I have to make a new Venn diagram to explain this. Let's take here. I don't know if it is visible or not. Let me draw a Venn diagram. Where should I draw? Let me draw a Venn diagram and show that whatever regions these are giving, same regions are given by this. So these two expressions are equal because the elements are same. This is your universal set. A complement is these region. These regions are A complement. Union B. So this part is from B. This is also included now. This is A complement union B. What is B complement union A? B complement is all of these regions. Okay, let me do it like this. B complement is these regions. And these also. Right? Now you are doing union A. So A is these elements from A are included. Now this is also included. To this you are performing intersection. So you are now going to exclude those regions which do not have both colors, green and orange. Intersection means it should include to both. So you have to remove these regions and these regions. So from De Morgan's law you got this, and when you can look at the Venn diagram, you are getting the right result. Okay, what about this? A intersection B include these region. Union A complement include all of this, but the region with B also. But then I am performing intersection with B complement. That it has to also come under B complement. So B complement, this B portion is gone. So it will only include all of this, right? So A intersection B complement will include these regions, all of these regions, and A intersection B include these regions. So this expression and this expression are same. Let's say this is set C. This is set C, and set this whole expression is set D, then what I can say that C and D are equal sets. C and D are equal sets because they have same elements. Okay, thank you. Let's look at set difference now. A minus B. We know that what is this A minus B? This is X, those elements of A that are not in B. Means from the elements of A, you are removing those elements that are in B also. That's why X, this is A, this is B. From this set A, you are removing these elements, right? So this is your A minus B. As you can see very clearly that this you can write it as A intersection. This you can write it as A and intersection S does not belongs to B. B complement. A intersection B complement, which is this region. Okay. So A minus B is equal to A intersection B complement. In one of the previous videos, I have come to this using Venn diagram also, right? From the Venn diagram, it is also quite clear that this region is nothing but A intersection B complement. So this is the part. My hand waving should be clear, right? Now, just look at this. A intersection B complement, what we can say is asymmetric difference B. We can say that asymmetric difference B is also A intersection B complement union B intersection A complement. This is what we know. It means that asymmetric difference B is A minus B union B minus A. Right? Okay, I will do it again. Asymmetric difference B, I can write this as it is these regions and these regions, right? So asymmetric difference B is A intersection B complement union B intersection A complement. In the last video we have seen that we are trying to get the complement of A intersection B. This is the complement of A symmetric difference B. But the formula of asymmetric difference B is this only, that asymmetric difference B is equal to A intersection B complement union B intersection A complement. And A intersection B complement is nothing but A minus B. A intersection B complement is A minus B. So it is A minus B union B minus A. And as you can see, this is nothing but A minus B and this is B minus A and then union of it. So these are some of the properties. Now let's try to find the complement of A set difference B. Let's try to find this. Okay. So I will remove that part now. A minus B complement. What does this mean? it means that X does not belongs to A minus B, right? It means what? X belongs to A. It means that X does not belongs to A minus B. It means that X does not belongs to A minus B is X belongs to A, and X does not belongs to B. So what I would do is X belongs to means A. So A का complement करेंगे. Look at this. You are performing. X does not belongs to this set. So you are in a way you are doing a complement on some operation. So here we will apply De Morgan's law now. So let me apply De Morgan's law. X belongs to A complement and becomes or X belongs to uh, X does not belongs to B means X belongs to B. Means X belongs to A, so X does not belongs to A. So that is X belongs to A complement. X does not belongs to B means X does not belongs to B complement means that X belongs to B. And this is nothing but A complement union B. Now let's see if this the region because in the Venn diagram because of this expression is this or not. Okay. So A minus B complement will include these regions. A minus B complement will include these regions, and these regions is nothing but A complement union B. A complement include everything, and because you are applying union B, then because of it these regions are also included in it. So this is true. So as you can see that what I'm saying is that you don't have to actually remember. You know, you can see there are many formulas. Uh, in any book, if you look at the books, there are many formulas, but all of them, it is from the very basic definition you can get to it. You just have to master De Morgan's law. So union, intersection, and complementation, the basic definitions you know, and then if you know the De Morgan's law, then you can arrive at this from here only. Okay, like I am just applying De Morgan's law directly from in this manner. So this you can think of it. You can think of it just in terms of set operations directly. How? What I am doing? A X belongs to A and X does not belongs to B. This is nothing but A intersection B complement directly. You can write it like this, and you are applying X does not belong to this means complement of it. Now from directly apply De Morgan's law. A complement union B. That's what it is. So I am writing it in this way, or you can change it here, and you can directly deal with set operations. It's the same thing. Okay, I think this is enough. It's very easy. If here it is or, it means you will or it means union. Belongs to, directly you write the set. Belongs to B, directly you write the set. So let me just summarize what we have seen so far. The formulas that we have seen so far. Let me just summarize it. But we know how to get to the bottom line. These are the three very fundamental set operations. And then we know about set difference A minus B, and we found that A minus B is A intersection B complement, and A symmetric difference B is equal to A minus B union B minus A, which is equal to A minus B in A intersection B complement union B minus A is B intersection A complement. Now let's get into operations involving three sets. And involving three sets, we have looked at the associative property that set union, intersection, and set symmetric difference. They are associative, but set difference is not associative. Now there is something called as distributive law. Now let's see that.